equations using those skills. So before we really begin this, you do need to remember something about solving equations, specifically the zero product property. So I'll give you a quick reminder what that says. The zero product property says that if you have one number A times another number B equaling 0, the only values that A and B could be would have to be 0. And you do have to make sure that you're solving for both, because 0 times a number gives you 0, and a number times 0 gives you 0. Do you guys remember that? The zero product property? Basically, we're going to take your skills that you did in the bell ringer and apply them with this property. Specifically, we are going to focus on solving higher degree equations. Degree represents an exponent. So last unit, you guys solved for x and x squared. In this unit, you're going to be looking at solving for x cubes and x to the fourths and x to the fifths and square roots and absolute value equations. So this unit, we're really focusing on solving higher level equations. Today, we focus on how you can solve using factoring. We're also going to bring in your understanding of I, where we're looking for solving for all the solutions. So any imaginary or complex solutions we get, we want to make sure we write in standard form. Okay, example 1. You guys warmed up your factoring skills. In example 1, before we can actually factor, what do you think we're going to have to do with this equation? Before I can actually factor. Weston? Nice. We need to set the equation equal to 0. So I'm going to put like an exclamation point here and just write exactly what Weston said. Set the equation equal to 0 first, especially if you're solving a higher degree equation. So we'll subtract 9x cubed, exactly what he said. And we get x to the 5th minus 9x cubed is equal to 0. Now we're looking for, in factoring, what's always the first thing you have to do? GCF. What would the GCF be here? What do they both have in common? Good, x cubed. So we would take that out, and we'd be left with x squared minus 9 is equal to 0. Quick reminder from our factoring unit, if you don't know the GCF, you can technically factor out each term and look for what's in common. So what's in common? X times x times x, x times x times x. And notice we're left with x squared minus 9. Okay, now can we factor this further? We did one like this on our bell ringer. What does x squared minus 9 factor down into? Good, x minus 3, x plus 3. And I need to keep x cubed on the outside. After you have it factored, you can use that zero product property to solve. So we'll set this factor, and this factor equal to 0, and then we'll solve for x. So I set x plus 3 equal to 0. This is a linear equation because x is just to the first power. How do you solve for x here? Good, subtract 3. Then you get x is equal to negative 3. X minus 3 is equal to 0. This is a linear equation. I would add 3, and I get x is equal to 3. X cubed is equal to 0. That's actually a cubic equation, but it's probably the easiest that you would see. You might even be able to just think through it. What times itself would give you 0? What times itself would give you 0? 0. So x is equal to 0. The other way to look at it, if you want to see how do I solve if I just have a number cubed, you could potentially take the cubed root and then ask yourself, what's the cubed root of 0? And that would be 0. Or the other way to look at it, if you really want to see one other way, you could say x cubed is really x times x times x. And so set x equal to 0 3 times, you're going to get x equals 0. So any way that you want to look at that, x does equal 0, but we get 0, 3, and negative 3. All right, number 2. This one already is equal to 0, so we want to be thinking, what's the GCF turn to your partner and the person who we've done youngest and oldest, right, in here? We've done tallest and shortest. What'd you say? Hair, longest hair? We done lightest hair? Biggest feet? We could, yeah, I mean, but then if you're, well, yeah, comparing shoe sizes, some people are self-conscious about their shoe sizes. You shouldn't be, but my sister is taller than me and she's very self-conscious about her shoe size. So I don't want anybody to feel self-conscious here. Yeah, darker hair color. You turn and try. You tell them what the GCF would be.
My natural hair color is like a brown, darkish brown. So
it's fine. I highlight, so I don't really.
Yeah, but I do have like a blonde balayage right now. So
okay, then I'm probably darker. So I'll take it out. It would be 2x to the 4th. And then you'd be left with x minus 9 equals 0. Yeah. All right. I'll continue with the class then. All right, guys. Did you take out 2x to the 4th? Yes. Now, does x minus 9 factor down any further? No, it's not x squared minus 9. So what do we do now? Just set it equal to 0. So set x minus 9 equal to 0. Do you know how to solve that? Yes. Yeah, add 9. And you get, yeah, x equals 9. Do you need to set 2 equal to 0? No, 2 can't equal 0. Right, it's on the outside. It doesn't affect your answer for x. But do we need to set x to the 4th equal to 0 and solve? No. Does it give us an answer? 0. So x is equal to 0 is the other solution. Because 0 times 0 times 0 times 0 would give me 0.
So you have like multiple answers.
You can definitely.
On how, like, you have to factor.
Actually, Haley, you're leading to something that we're going to learn next semester. If you have a degree of 5, that really gives you an insight into how many solutions you have. We really have 5 here.
So how do we do that?
Why do we have 2 shown? Any ideas? Well, x to the 4th is really x times x times x times x. So this is actually called a repeated 0. It's the same number. It just happens 4 times.
That's kind of pointless.
It is kind of pointless, but it gives you an insight into like, hey, if I'm looking, do I really have all the solutions shown? And we can see that, yes, we have 4 solutions there. They just equal 1 value. All right, but we'll get there. Let's move on to example 3. Example 3, that should look familiar to you based off of what we just did. How do we go about factoring something like example 3? Grouping. Group the first 2 terms and the last 2 terms. What's the GCF of the first 2? Good, x squared, and we'd be left with x minus 5. What do we copy over? Good, x minus 5. And then we have to ask ourselves, what times x would create a negative 2x? Negative 2, and then check. Here's your built-in check step. What's negative 2 times negative 5? 10, so we got it right. And now, what's the GCF that I can take out? X minus 5. Good, and then I group x squared minus 2 and set that equal to 0. And now I set each factor equal to 0 and solve. So x minus 5 equal to 0. Do we know how to solve for x in this equation? The minus 2?
Yeah.
It came here.
Yeah, I know. But when you're saying it equal to 0.
Oh, we'll look at that. That's a good question. Okay, so here we get x is equal to 5. But now Haley's leading us to this other one. If we set x squared, so we looked at in the last chapter what you can do if you have a quadratic. There were 4 methods that you guys learned. Taking the square root, factoring, completing the square, or quadratic formula. If you just have an x squared and no other stray x terms, which of those 4 methods is easiest to solve? Square roots. So how are we going to solve by taking the square root? Basically, how do we get x squared by itself? Add 2. So we'll do x squared is equal to 2. Now we can take the square root. What undoes a square? Square root. And what do I need to keep in mind when taking the square root?
Plus
Plus or minus. Nice. So as you're thinking about solving these equations, if you see something squared, you want to think about those 4 methods that we looked at. Take the square root to solve, factoring, quadratic formula, or completing the square. And I know you guys are pretty good with these because I graded the last test and you guys did a great job. Mario, yes. Okay, example 4. Example 4, I'll tell you the most common mistake. The most common mistake I see is that people try to add the 8 and take the cubed root. They find the real solution, but they miss 2 other solutions. They miss the imaginary solutions. So let me tell you how you should go instead about solving this. Actually, maybe you know from the bell ringer I gave you. Can we factor x cubed minus 8? Yes, if you don't remember the rule, here's where I would write it, because if you lose that bell ringer, here it is in your notes. A cubed minus b cubed factors down into a minus b times a squared plus ab plus b squared. Okay, this time, the person with the lightest hair in the group, you turn and share what this would factor down into.
Okay, so you would start off with x minus 2.
Nice.
Since that's what it's factored down to, x to the third minus 2 to the third. And then you would use the formula, which after you do that, it would be x squared plus 2x. And then it would be plus 2 squared, but that would be 4.
Awesome. You got it. Perfect. All right, guys, you should have this factorization. Katie. Yes. Okay, now that we're here, you might see this quadratic and think, can I factor that further? But sadly, you cannot. So now we would just set each of these equal to 0 and solve. So we'd set x minus 2 equal to 0. Do you know how to solve that? Hopefully. What do we do? Add the 2, we get x is equal to 2. That one's done. And then we set this one equal to 0 and solve. Hopefully you're noticing this is a quadratic. It has an x squared. So you could try to factor it. If I try to factor it, the last term's positive and I need the same sign as the middle term. Are there any factors of 4 that will add up to 2? 4 and 1, 2 and 2. No, nothing that will add up to 2. So can we take the square root? No, because there's an x here. We could do the quadratic formula, or what else? Completing the square. Remember when it's easy to complete the square. When is it easy to complete the square? When what? What'd you say? When the x squared has a coefficient of 1, yes, and when the middle term is even, because it's easy to divide the middle term by 2 when it's even. So it is actually easy to complete the square here. You guys tell me, do you want to do the quadratic formula or completing the square? Okay, let's complete the square then. What do we have to do with that 4 first? Good, subtract it to the other side. So we get x squared plus 2x is equal to negative 4. And then in completing the square, you're going to take half of the middle number. So what is 2 divided by 2? 1, and then we square that. What's 1 squared? 1. And if I add it to this side, what do I have to do? Add it to the other side. Good. The reason we did that is so we could factor this down. You know it's going to factor into something squared. If you're unsure what, you can just break it down like we've done in the past. The last term is positive. The middle term is positive, so we know we're going to have the same sign as the middle term. X times x would give me x squared. What times what gives you 1? 1 and 1. So this factors down into x plus 1 squared equals, what's negative 4 plus 1? Negative 3. Now we can take the square root. What undoes a square? Square root. What do I have to keep in mind when taking a square root? Plus or minus. And in the past, You might have said no real solution, but now you know what type of solution this is. It's an imaginary solution, and you should know how to simplify square root of -3. How do we simplify square root of -3? Nice. It's I root 3. Now, I'm fine with you guys jumping to that answer. We learned the why. The reason is because this is the square root of -1 times the square root of 3. And what is the square root of -1? I. So that's the key. But now that you've worked with I, I'm fine with, if you see that negative, just bring it to the outside of the radical and call it I.
What happens to the other one?
Oh, I'm not done. Good question. So now I do have to get x by itself. So what do I have to do with this +1? Minus it. Nice. And we have x is equal to -1 plus or minus I root 3. So there's our two imaginary solutions. This is a cubic. So we did have three. There's my video. We did have 3 solutions. Because there's 1 here and then the 2 here. All right. Back page. The last type of equations we look at today are equations that are quadratic in form. They might not look like a quadratic, but they actually are quadratics in disguise. Quadratic, that's a math word. Whenever I see a math word, I like to see a visual example. A quadratic looks like this: ax squared plus bx plus c. So these are quadratics in disguise. You're going to have to use something called U substitution to help you actually see the quadratic better. So if I look at example 1, I can actually write this as 4 times something squared minus 8 times something plus 3. I have to really determine what should I let U replace that would make this fit this format. Allison? Nice. If we look at this as 4 times x squared squared, why can we do that? What happens when you raise an exponent to an exponent? When you multiply two numbers with the same base, you add them. When you raise an exponent to an exponent, I guess, yeah, it does kind of work similar here because of 2 plus 2 is 4 and 2 times 2 is 4. But just as review for the final, you multiply. So in this case, it does work out. 2 times 2 gives you 4. And I notice that x squared is already here. So I'm going to put U here and here. And now this is a quadratic. You could use completing the square. You could use quadratic formula. I personally think factoring this one is easiest. So let's go ahead and factor it down. The last term is positive. Does that mean I'm going to have the same or different signs? Use the other guess. Same? What should they be the same of? Negative? What times what would give me 4u squared? 2u and 2u? What times what would give me 3? 3 and 1? And let's check it. Does it add to the OI in FOIL? What's negative 2u plus negative 6u? Negative 8u, so it works. Okay, now what do we do next? Yep, copy it over, set them each equal to 0. So I have 2u minus 1 equals 0 and 2u minus 3 equals 0. Oh, and I forgot to write down what Allison said. We're going to let u replace x squared to make it look like this nice, pretty quadratic. Now, let's go about solving for u. So what do you do first if I'm on this equation on the left? Close. That you do second. Add 3. And that would give you 2u is equal to 3. And then you divide by 2. So we have u is equal to 3 halves. Were we solving for u? What were we solving for? X. So what do I need to do now? We're solving for, well, yeah, we need to solve for what is x, but what did u represent? X squared. So we've got to put that back in. And nice. We know how to solve this because it's just an x squared. So what undoes a square? Square root. What do I need to keep in mind when taking a square root? Plus or minus, and I also have to do what, Freddie? Nice. Freddie remembered that root 3/2 is really root 3/2. And then he even remembered that we can't leave a square root in the denominator. So he reminded us that all we have to do is multiply by what's in the denominator to the top and the bottom. And then this will become root 6/2. Mhm.
You still have to do the two.
Yes. So I was going to ask you, turn to your partner and let's do the oldest. You share what you would do to solve for u of 2u minus 1.
Where'd you get 6?
Because of what's root 3 times root 2?
Oh, it's wait, u equals.
U equals 3/2. And then u represents x squared. Okay. Olivia, I guess I'm the oldest.
I can
So
ask a question real quick. Sorry, I forgot. Why do we multiply the denominator by like square root of 2 times square root of 2 again?
because you can't leave a radical in the denominator.
Okay.
We'll rationalize the denominator. And so to do that, we multiply it really by itself over by itself.
Okay. Which then cancels. Okay.
Yes, because root 2 times root 2 is just 2.
Mm-hmm.
Nice. Okay, if we solve for u here, we'll add 1. So we get 2u equals 1. And then divide by 2. So we get u is equal to 1/2. But then I have to put x squared back in for u. Yes. So I have x squared is equal to 1/2. And then to undo the square, we square root it. So I have x is equal to plus or minus, but this is really root 1 over root 2. So how do we rationalize that denominator?
Then you times it by square root of 2.
Awesome. So then it'd be root 2/2, but I got to remember that plus or minus.
Oh, I'm able to have.
Awesome.
You can, yeah.
Because I had that and I kind of stopped.
It looks funny, I know.
Yeah.
All right, guys, how do we do? Did we get plus or minus root 2/2? All right, the last one, I personally think example 2 is easier than example 1. What would you let u replace in example 2? Good, z minus 4. So we would have u squared plus 4 times u plus 3 equals 0. How would you guys want to solve this quadratic? Could complete the square. Could do quadratic formula. Mario, you say we could factor. I do actually think factoring works nicely here. The last term's positive, so should we have the same or different signs? Same. U times u would give me u squared. What times what gives you 3? 3 and 1. What do we do now? Oh, yep, check the OI. Does the outside and the inside add up to 4u? Yeah. Good, copy it over, set it equal to 0. So copy each of these over. Solve for u. So I'll subtract 1, and I get u is equal to -1. But I'm not trying to solve for u. What am I trying to solve for? Z. So I need to put z minus 4 back in. And I have z minus 4 is equal to -1. How do I get z by itself there? Good. Add 4, and we would have z is equal to 3. And then we got to solve for the other one as well. So we subtract 3, and we get u is equal to -3. Put z minus 4 back in for u. And that should be equal to -3. And what's the last thing I have to do to get z by itself? Add 4, nice. So we get z is also equal to 1. All right, I need to pick 3 road to excellence. Your homework tonight is possibly twofold. If you understood last night's homework and you don't have to fix anything, that's fine, then it's just this lesson. But if you left any question marks on yesterday's homework, go back through after we reviewed those questions, try them again so you can get full credit on that assignment.